Hello, so in this video I'm going to go through a couple of examples of what seems like a very simple equation but can basically catch you out in exams. So my first question is, what is your velocity if you travel 20 meters in 5 seconds? Most of you will straight away in your head go, oh, it's 4 meters per second, but I want you to look at how we would approach this in case it became more difficult. So first thing, I would circle the information in the question and I would annotate next to it what it is. So 20 is my displacement, 5 seconds is going to be my time. Now as a good student I'm going to write down the equation v equals s over t. Then I'm going to put the numbers in, doesn't take long at all, 20 divided by 5, and then I'm going to work it out. So it's going to be 4 meters per second, and I am definitely going to remember to put the unit. And that seems really simple, but how could they make it more challenging? So look what they might do to you. Imagine if they gave you a question like this. What is your velocity? I'm not going to write out the full question. If you went, I don't know, 23 meters in 7 seconds. Now, same bit at the start, circle it, time, displacement, v equals s over t equals 23 over 7 equals, and this is where people go wrong, because look, if you do that on a calculator, I think it comes out at, I've prepared this in advance, I can't do it in my head, 3.28571428. You would lose a mark for that. That's too many decimal places. So how many should you use? Now if you go back to the question here, there were 2 significant figures in that question. I probably should have written 7.0 here. So I should write 3 point, and to 2 significant figures it means I need to round this to 3.3 meters per second. There's another one that catches people out that would be correct in maths but would be marked wrong in a physics exam, and there is a reason, I'll explain, but look, what is your velocity? I can't write. What is your velocity if you went 22 meters in 7 seconds? Now if you work that one out, you would get v equals s over t, displacement over time, equals 22 over 7 equals, and my calculator says 3.3 with a dot over it. Now that dot means recurring forever, and that is not acceptable for us, because in physics, unlike maths, we're not looking at pure numbers. What we're looking at are things that we've made measurements of, and we can't measure things to an infinite number of decimal places. So if you see this with a dot, or your calculator shows something like this, you always need to round it. 3.3 meters per second again. Okay, now there's one other thing that I want to show you very quickly, and I'll get a new piece of paper for that. And it would be, what distance do you travel if you move at 20 meters per second for 1 minute? Right, so first of all, circle them. 20 meters per second, that's my velocity. 1 minute, that should set off an alarm in my head. That's not seconds. So I'm now going to change that at this point to seconds. So that's 60 seconds, isn't it? And that is my time. And now what I'm going to do is write down the equation. V equals S over T. And what the examiner likes you to do is just put those numbers in without rearranging it. And it seems like an unnecessary step, but they will give you a mark if you go wrong with something else. So that would mean that I will write 20 equals S, the displacement we're trying to find out, divided by 60. Now, some of you might instantly be able to change the subject of the equation and be able to solve that. I would probably do this, though, just to make sure. I would use my equation triangle, and I would say S, V, T, and I would see that the displacement, the thing we're trying to find out, or distance in this case I've written, I said I would do something wrong earlier on, is equal to the velocity times the time. So S equals V times T equals 20 times 60 equals 1,200 metres. Now you can practice some. Thanks everyone, have a good day.